Greetings all. Thank you for joining. It's June 8th, and Shingai will have a presentation of some sort. We'll talk about the upcoming ISSS conference and check in on some other topics. But how about you can present first, Shingai? We'll just start there.
Okay, that sounds great. I will throw this presentation into the chat so you can see the slides. Let me know if you're able to access it. Just threw this together this morning, so it's a little rough around the edges, but hope it will stimulate some interesting discussion. Okay, so can I share my screen? Yeah.
Yeah.
Yeah, cool. Share screen.
Nice. Looks great.
Okay, cool. Okay, so the purpose of this presentation is to explore what it might look like to do some research around developing a systems language. So yeah, overall goal would be to develop a working prototype of a systems language as described in George's latest textbook, System Science, Theory, Analysis, Modeling, and Design. And here I will cover what is a systems language, the key components of a systems language, and how we might be able to work with CAD in order to accomplish this goal.
Shingai, could you put that on presentation mode?
Absolutely.
It's really small.
Yep, absolutely. Okay. Is that better?
Yeah, much better, thanks.
Okay, great. Okay, so what is a systems language? It is a formal language for defining systems in any domain. This would be useful for modeling and visualization in business, government, science, and it is a description language for describing the structures, relations, and functions, plus the other items in the systems ontology outlined in the textbook. And the relations between the elements would be specified in the syntax. So this would have a lot more in common with something like HTML or XML than a scripting language like JavaScript or something like Python. So the first component that kind of sits at the core of this language is the mathematical definition of a system proposed in the textbook, which is derived from the system's ontology. This provides a structure for holding the details of a system's description. And in the textbook, it's presented as we are using math more so than doing math. Here's a quick glimpse at the systems ontology from which the mathematical framework is derived. Not going to go too deep into it in this moment. And then here is the mathematical definition of a system. It's a little bit blurry, but hopefully you can still see. Details of each of these components are in the presentation notes, but basically a system is a tuple composed of these 7 elements. C represents a set of all of the components within the system. N is a graph that represents the interactions between the system's internal components. G is another graph that represents the interactions between the system's components and its environment. B represents systems boundaries. T is a set of transformation functions that describes how the system's components turn inputs into outputs. H is a description of the system's state or the system's memory of all of its states over time. And then T is a time step. Okay, so that's...
Can I
absolutely.
Word here.
Please, please.
Important to note that we're talking about a single level of a system. So in the sense of a holarchy, this set of components is the set of components at that level I. And then each component in that can itself be then decomposed as a system unto itself. So I can't think what I was going to say now. So anyway, it's important to note that this equation 4.1 goes in along with a subsequent equation that defines that recursion, that recursive structure.
Yep. Yeah. In that context, I will add an additional slide describing that because that is a really important piece of the puzzle. Thank you. Okay. So a second component of the systems language would be a graphical user interface. So a front end that would have icons and a drag and drop menu. I recently came across an open source systems diagramming project called TL-Draw, which seems to provide most of the functionality as something like a lucid chart, but it's open source, it's based in JavaScript, and so I can imagine that something like this might be helpful for creating this GUI. But on the left-hand side here, you have some of the key components of a system. So I think, George, correct me if I'm wrong, but the idea is that the user would drag these components into a systems diagram, and then they would be prompted with something like the screen on the right, and then the user would sort of define like the name of the component and put in a description.
Yeah, that's basically right. Now, I want to hasten to point out that these are icons that I came up with in using PowerPoint. So somebody who is really good at front-end development and graphics and things like that would probably come up with much better representations.
Yeah.
But that's just a side note.
Okay. And then the third component is the markup language. So this would be something very similar to HTML/XML, possibly an extension of XML. And it's named in the book as ISSS. And basically, when the user drags the icons from the previous slide into the systems diagram, the system would automatically output this markup language as output. And so
this might be a good point.
Mm-hmm.
I'm sorry. Okay. This might be a good point. Could you go back to the previous slide?
Absolutely.
This might be a good point to point in this to note that the because of that mathematical structure that we had, you have embedded within there the T set, which is the functions that go along with that particular component, say. And so as a consequence, while this is a markup language as such, there are internal links to go to actual functional. And those functions are all linked by virtue of that mathematical framework. So in the end objective is you could essentially push a button and generate a simulation model because all those things are already available. And it's not just a structural model then, but rather you could actually have a simulation model.
Yeah, thank you. Please continue to interject whenever you have more to add. This is helpful. Okay, so in the textbook, the example of a sort of basic model of a steel plant is used to show how this might work out in practice. And it is emphasized that this is all very, there's a lot of research to be done to make this into reality. And this is just designed to give a sense of how it might work. So you have a steel plant as the system of interest. You have various sources on the left and various sinks on the right. And so this is the graphical version. And then here is the XML output that is associated with that graphic. So you have the system of interest, you have descriptions, and yeah, this is what SysXML might look like in practice. Any notes there, George? Or?
Well, just to, again, to emphasize the fact that what I put in the book should be considered as a preliminary outline. So while it looks very, technically complete and all that kind of stuff, I didn't have people going through and checking to make sure that there was internal consistency, or even completeness. So again, it's just trying to spur exactly what you're doing right now, Shanghai, which is taking that and saying, oh, okay, we could probably use this. And then hopefully people will be able to go in and flesh out any things that might be missing.
Absolutely. Okay, and then the final component is that you would need an algorithmic or a scripting language in order to actually specify the operations of the behaviors of the different elements. In the book, you mentioned JavaScript as good candidates. That makes sense to me, although I'm curious if anyone would make a case for any alternatives to JavaScript. And then the final component is the systems knowledge base. So you described this, George, during our last meeting as a systems engineering approach to constructing knowledge that is retrievable, usable, as it's discovered through the process of an analysis. And this could be for a specific system or for a generalized system. In the textbook, it's outlined and described as a traditional relational database management system. But it seems like implementing it as a graph database might be more suitable. So that's something to explore. And you have a hypothesis that this is actually how the brain encodes and decodes knowledge. And again, here's just a graphical depiction of how this sort of relational database might be organized and how it might actually look. So we had talked about sort of integration with things like CAD, which is an existing really great system for modeling complex systems. I feel like this is an area where I could really use some help thinking through how to approach this. So we'd asked last time, how could we replicate parts of what George has laid out in CAD blocks? And as I've been sort of re-familiarizing myself with CAD, looking at some of their recent papers, basically they are integrating generalized dynamical systems as a framework, a mathematical framework that CAD will be operating on. And this is a framework that's very focused on describing how one state evolves into another state over time and representing system states and dynamics. And it's based on category theory. And this is in contrast with George's systems language, which seems to be a lot more focused on describing the structure of a system, the function of a system, and the relationships within the system, and also between the system and its environment. So I'm wondering if we would look at CAD as a means for like modeling and capturing the state variable in George's mathematical description, or if there is a completely different way to look at this and what it actually might look like to implement some of George's work on top of CAD. So my personal next steps are to re-familiarize myself with CAD, retake their online course. That's an intro to their software, to read the next chapter in George's book, and would love to work on sketching out a research roadmap with anyone who wants to help out.
Excellent.
Yeah, awesome.
Yeah, the CAD CAM, what was I going to say? Oh, yeah. So you were linking that to the systems dynamics aspect.
Mm-hmm.
So I'll go back and note that if the functions that are embedded, when we were talking about JavaScript as a language to implement those, but those functions are embedded in each one of those C components, that when they are linked, and maybe CAD/CAM will actually provide that capacity, but that then becomes the system dynamic model of the system that you've just been constructing, analyzing, building, and so forth.
Mm-hmm.
Yeah, I'm super excited and supportive of it. However you want to develop the kind of research program, ultimately, whatever extent we want to do it here in education, just say, this is what we're basically working on in education. It's all good to include the different aspects of systems education that people have brought up. However, such efforts are ad hoc, tentative, or triage at best without the underlying artifact and systems that we need, which is really what you described with the writing and the markdown language, the triple play, the ability to have the visualization, the natural language, different human languages, and the executable simulation. And then understanding the formal categorical structure and the continuous quantitative statistical nature that helps us actually connect to the observations. CAD seems like the way to make this happen. I'm not familiar right now with the CAD reference implementation, but if that is getting stabilized, and their recent papers are about the GDS and the category theory, then I think it's definitely possible.
Okay, absolutely. Can you think of anyone at CAD that would be a good person to chat with? I think I know Chris Katoya is one person. Who would you reach out to?
Yeah, Chris is great, and I think in like a sort of community management role. Then Zargum and Jeff Emmett and Jessica Z as well. But we could invite them here at a given time. We could discuss at a block science office hours. We submitted a grant with block science almost a year ago. Haven't heard back on it, but it was more about knowledge management, but using CAD to understand those kinds of information systems. So if we're familiar enough to develop it.
Okay, sounds great. Well, keep working on this and keep everyone updated.
Also, it reminds me of this will be the specification is not completed, but there's hyperspace modeling language, and then HSTP, which is the transfer protocol. HSML and HSTP in terms of the like spatial semantic web and using active inference.
Oh, I'm sorry.
Yeah, please, George.
So my department at the university, we have a PhD program in computer science, but we've the technical name of the department is computer science and systems. And while we have never really done anything, with the systems other than the stuff that I tried to do, it is possible that if someone were looking to get a PhD in this area, in developing, doing the research on all of these questions, which Shanghai, you're doing a great job of bringing out what the areas that we need to be looking at are, but it will take, I think, the kind of effort that a PhD student or students doing their dissertation research on this kind of a subject would be. And it fits into computer science because it's all based on, how we're going to use a computer to implement these languages, which is classical computer science topical stuff. So if you know anybody who's really interested in pursuing a PhD, let's get together and talk about it and see. I'm emeritus, so I can still be a advisor for a PhD student. And we are open to outsiders being on the committee, on the PhD committee for students. So any of you guys might qualify to come in and work on that stuff. So keep that as an option in mind, but we don't want to let it go too long because I don't know how long I'm going to be able to hold up here.
Does anybody want another PhD? Or a first one?
I just came up with my framework, so it's got connections with ISSS, but not.
Thank you, George. This is awesome. I've never been on an external committee, but if it were relevant, I would do it. And that's why I even said it was like a research program, because there's multiple pieces to bring together, and some of it is going to require research and development. But there could be how can we refine this possibility and communicate it to people who may be looking for a PhD?
Well, there could be an announcement at the conference, I guess. That's a really good question, because the people over the years, I've talked to several people who have been wanting to pursue a PhD in computer science, but they typically, most of them have been wanting to do it relative to my, machine learning / robotics kind of work. And that takes a huge budget. You've got to do robotics, you need money. And so that hasn't been something I've wanted to actively pursue necessarily. Whereas this project is much more intellectual. It doesn't require any great hardware above, standard computing. So it's not the kind of thing that would be very, very costly. But we will, it would have to be someone who wants to get a PhD in computer science, which, by the way, is a pretty good idea in and of itself, because you can get a recognized job doing that. Whereas if you say you're getting a PhD in system science, well, people are going to say, what does that mean? Is that computer science? So this way you can say yes. So I'm not sure where you come into contact with those people, and I'm no longer, if there were associates of mine at the university who are also doing this kind of thing, we would probably be able to generate a pool. And if I weren't retired, we could probably generate a pool of interested students. But as of right now, I'm sort of kind of far away from all that activity. So I don't know.
Yeah, I have one person, a friend of mine, who I don't know if he is interested in getting a PhD, but my friend Michael, who has a BS in bioengineering and computer engineering, spent some time doing software engineering in the space industry, and is now taking some time off. And he's actually doing a deep dive into your book after I recommended it to him. So if that is something he wants to do, then I think he could be a good candidate. So I will reach out to him. Maybe he knows other people, but he seems like the type of person who would be a great fit for this.
Okay.
Also, I can announce something in the complexity and in the active inference communities. If we can have a postable, or
Yeah, I'll get the link to the PhD program description at the university, and then maybe write a little screed that says, this is a PhD in computer science. However, the project has a much larger scope in terms of being related to general system science. And, we'll see where that goes.
That'd be awesome. Cool. Yeah, well, we can increment and start to develop this research agenda. I mean, whether it's any of us or otherwise, but we can develop a hierarchical task allocation, and at least begin to map out, like, we need to do the specification, we like coming from the book, extracting out the different requirements for each of the variables, essentially, and then look at which tools or approaches can be used for each component. What are the other functionalities of the front end and the back end that would be needed? Start to just get some of that out so that people can see more. Carl, that link is just not
Yeah, no,
link
that's,
out yeah.
I had wanted to post something else and I had already kind of drafted that up, but that was the, that was basically what was worked on yesterday, and stuff, and Giannis and Gary's.
way back in 2023.
Oh, 2003. Sorry.
I remember it like it was yesterday.
Yeah, exactly.
It was from 2003, and what was the initiative, or like what was it about?
It was using that to kind of go through some of the just describe that STD process and how we would implement it. So comparing pairs, but I didn't want to. I was going to post that at the end. Didn't want to interrupt. I did want to post. I had looked at a PhD program at George Mason on computational social sciences, but I decided I wanted to focus more on human systems. But just wanted to. I can check around and see if any of my network is involved with that.
Yeah, well, but this would be a good timing for in terms of the application cycle, hopefully. So thanks again, George, for bringing it up. I mean, we can move to another topic, or we can begin to just sketch out the directions of this project in more detail.
I've just got a quick question, if that's all right. So George's framework, which I haven't seen in its entirety before, is that being made part of the educational framework in any direct fashion, or part of this knowledge engineering project in any sort of direct fashion yet?
We want it to be, and it's been something that we've been, well, Shingai with developing the newsletter, but I mean, talked about it and explored especially the ontology work in chapter 3. You can follow my like little token around in terms of some summarization of chapter 3 and 4, because we earlier on recognized that the systemese, language modeling, however you want to talk about this, that is the interoperability within and between education and knowledge engineering.
Okay, and so that's an obvious question. Thanks. I just didn't.
Okay, no, it's a critical question though. Like it just, but we are able to have the tuple, or we're able to have this, but we don't have that for ISSS, or like for our resources specifically. And so, I mean, here's that equation. it's just an equation in text. It's not. And then we talked a lot about, and we shared a lot about George's experiences with education around this material, where there's been some publications and just other experiences, and like, yeah,
Okay.
educating at the university level around this material and doing that in the kind of project-based ways. And
Okay. Because it seems to me that, again, I'm probably saying this, that it's sometimes hard to get things done when you have too many options. So if you say, let's use George as much as possible, then you're able to focus on getting as much done that you can that sort of tags or reacts consistent with George's model, and you'll also find what doesn't work with that. So that even just to be able to, in the knowledge engineering context and in the context of the large language models, if goal one is just figure out for a given paper or abstract or article, which of George's concepts is this mapped to or not, and how much of it is unmapped, that could be just useful in itself without taking it too far. That's kind of what I was thinking. But I may be talking gibberish.
no, I think that's basically our move. Of course, unfolding in a kind of volunteer way. That there's no other preferable, let alone serious, alternative, plausible center of gravity for the kind of pluralistic systemese and system science that we need.
Okay. So I'm very happy to muck in and see what I can do, although I don't know what that means to do some practical mapping work.
Shingai, can we make a sub page and start to break out some of these, like basically like chapters in a dissertation,
Mm-hmm.
and just we can start to develop this.
Absolutely. Yeah.
All right. We'll just put it at, we'll just call it sysxml, but that's just a file type. All right. Well, do any of your slides have any high level structuring of the different paths?
No.
All right. The next step, I mean, that is the sketch out the research roadmap.
Yeah.
Yeah. Okay. Yeah, anyone can go to this page in the coda and oh, thank you, George, for that. But we'll wait to share it more until you've written else what else you want to have.
Yeah, I'd suggest that including, I can't remember the number, I think it's 4.3 though. So you've got 4.1, 4.2, which is the list of components.
Mhm.
And then the down below that is the recursion relation that
Mhm.
shows how each component is itself a system at the next level. And you might want to include that in the slides just to show that that accounts for the holarchy
Yeah.
conceptualization.
Daniel, can I share screen quickly?
Yeah. Yep.
Cool. Mhm. Okay, is it this one, 4.6? Are you seeing?
I can't really see that. I see the figure, the diagram.
Okay, is it too small or? Hold on.
Yeah, it's really quite small. It's equation, I guess I can look it up, 4.1, I think, or 4.3.
4.3. Oh, here we go.
There it is.
One. Okay. Cool. All right. I'll add it in there.
Yeah. And we'll be able to use the renormalization group in certain settings, or use meta topology or a category theory for this kind of multi-scale modeling. CAD should facilitate that, but definitely we need to understand and document it a lot better. Okay. The chapters that are relevant for basically the specification of systemies, chapter 3 and chapter 4, or are there other chapters that are important to consider on that?
Those are the ones that establish, well, let's see, chapter 2, chapter 3, and chapter 4 all pretty much go together. The knowledge base is, I think, is that chapter 5?
I think chapter 8, actually. Chapter 8 for the knowledge base.
Oh, yeah, to where the details are, right.
Yeah.
Okay. Okay. And 3. Okay. So would chapters 2, 3, 4, and 8 compose a specification? At least the first just draft of a specification.
Hold on. It's a very broad topic, so it's kind of spread out. The other part of it, oh, where is it? All right, so chapter 5, that's what I was thinking before. Chapter 5 provides what is a structural framework for the entire process. So whatever language tools and knowledge-based tools and so forth are being developed would be contained within this. So I'm looking at page 228. Pardon me. 228, the diagram, which shows the overall process of systems analysis. And yeah, there you go.
Okay.
So that just kind of shows where it would be. And so anybody who's tackling any one of those ovals would need to know how it fits in with the other pieces.
Okay, so in terms of the systems engineering, with the system of interest being the deployed systemies, the operations of systemies, our system of interest is described in figure 5.1.
Right.
Okay. Yeah. And then the more like focal or practice / perspective dependent material are described mainly in 2, 3, 4, and 8.
Right.
Okay. So 2 is describing which aspect?
Well, that's the ontology. That's one of the
Okay.
the
3.
3 is the oh, wait a minute. Let me Shanghai, help me.
I thought 3 was ontology, but
No. Hold on a second. Sorry.
no, it's all good.
I'm on mute. Sorry. Chapter 2 is reviewing principles of system science. Chapter 3 is ontology.
Oh, yeah. Okay. 3 is, yeah. So chapter 2 really isn't necessary as a part of this. Chapter
Okay.
3, ontology. Chapter 4 is language. Chapter 5 is overall process.
Okay, so really
And
3, 4, and 5, and then 8 is the knowledge component.
right.
Okay. So if we were able to process 3, 4, 5, and 8, we'd have the specification that would have Markov blanketed off the text itself. So we could put the textbook.pdf behind us at that point. Of course, we could still reference it, but we would have taken the needed info. We would then be moving forward and versioning only around this system of interest rather than the more pedagogical concerns of the textbook, obviously. Then we have some research avenues related to CAD-CAD. First, we need to understand better how CAD-CAD uses dynamical systems modeling. We need to understand better how CAD-CAD is using category theory. I'll put into the chat, this was a live stream yesterday on compositional foundations for Bayesian brain. So we've been working on this for the last 6 months or so, but yesterday was the first of the 2 conversations with Toby, the author. It's his dissertation. So this was I mean, I can't recommend it since we did it ourselves, but no, it's awesome. It was a very good discussion, and applied category theory is going to be the way. Then with these 2, we can map specifications to each other. We'll be able to understand, are there things that we had distilled from 3, 4, 5, 8 that we don't feel like we can address within CAD-CAD? Or as much as possible, we'll try to make this specification here's the synthetic specification of the above. These are just distillation tasks. Then we have a synthetic total analysis of what we need. This is what moves forward. So then we have understanding CAD-CAD better. I took the course as well, but that was like a few years ago, and the reference implementation is different, and like obviously it's a challenging thing to work with. But they're very kind, so I believe that they should be supportive. Then we map GDS, CT, CAD-CAD, RI. That's the reference implementation for non-CAD-CAD people. They were like 0.4, and they were doing like some breaking changes over multiple years, though still using it in high reliability settings. But now they've basically coalesced on a real reference implementation. We map their reference implementation to basically the draft reference implementation of the system's language. Then here we have front and back end. Those are possibly commoditized areas. Like we don't need to invent something necessarily on the graphical interface side, if we can find a few examples of things that are similar that we like. Although also, I know that the triple play and being able to say, oh, here's two nodes, can we just connect them and simulate them and add another node? Those kinds of capacities have always been lacking, which is why there's like a lot of static diagrams, non-visualized simulations, natural language descriptions that don't go anywhere, all of that. But then there are steps to actually, and then how would we proceed? Let's just say we had this the technical specification and the language specification. Would we choose a set of systems of interest and pursue them?
Well, that's always been a major stumbling block. Pardon me. I would say yes. That would be probably the way I would go. But we'd also have to be careful to choose. And this gets back to sort of an educational program that might be master's level work as opposed to PhD level work. But somebody who's really big on organizations, for example, modeling organizations, could tackle it. Somebody else who's really big on modeling cellular metabolism could tackle it. So just a couple of examples far enough apart that they demonstrate the power of the general theory itself, the general framework itself.
Yes.
Yes.
But develop I mean, express the system in systemese.
What would be really powerful is if you go through that exercise on some system of interest, and then through the simulation and fussing around with the inputs and whatnot, make a prediction on behavior that either acts as a post-diction. You go back and look at the real system, and lo and behold, there's that behavior. Or better yet, you make a prediction and then go somehow fiddle with the real physical system, and lo and behold, there you get the behavior. That would be real science.
Yes. Backtesting until you're intervening forward. Discover some new metabolic balance. What other tasks do you think would be relevant? Like if this chapter were essentially like bottlenecking and specifying systemese, system of interest, including all of these components. This chapter were related to integration of dynamical systems and category theory with a executable aspects of CAD. This were standard front and back end development, and this were use case description and implementation. Do you think there's any other like major areas or other tasks?
Well, I don't know. Would this go in the use to? I can't read it.
Back testing and prediction.
Testing and prediction. Okay. Yeah, and verification. So any of those.
Yeah. Yeah, life cycle engineering. So this is the enormous core system science work. This is the computer science and analytical maths work. This is computational. Chris?
Just, I'm always a big favor of looking for things that don't fit, that don't work well, because that's science too. Yeah, I think this is all great.
Can you explain what you mean by what does not fit?
Like there may be
Well,
some
you can set up a situation and make predictions, etc., but you might not be able to do it. Like something might not work, and that's because there's something missing. And until you, so things that fail in testing also give information.
Oh, okay. Yeah. No, I agree with that. I just didn't understand that does not fit.
but I interpreted it at a slightly other level as well. Yes. Iterating and doing causal interventions to refine model of a system. But here I was thinking, as much of the specification that can be fit into CAD, just using CAD, in the broad sense, if the entire specification could fit into CAD, then, the train is leaving the station. Whereas there might be some functionalities that are outlined that cannot currently be done in CAD. And then so with the vision of getting everything into CAD, there might be some functionalities that are required, like straightforward multi-scale nesting is like very non-trivial. I doubt that they have that working well, but that's going to be one of the core components of this. But on the other hand, the good news is that we'll be able to describe systems long before executing them, even though the description and the execution are using the same language.
And I'll put one more spin on it. I'm getting involved in a actuarial AI project, and the part I'm trying to bring to bear is being able to predict where it works well and where it works less well, and why. And that same kind of question applies here: is where does this approach work well and why, and where does it work less well and why? Because in the end, people need confidence why they want to use it, so they want to learn from experts, where the low-hanging fruit is, where the problems might be, so they don't overcommit.
One thought that comes up for me when you say that, another aspect of George's framework is a formal measure of complexity. And I wonder if you could hypothesize that the higher that complexity, the less you will be able to predict and have successful causal interventions.
That's almost assured. Yeah, but what this is attempting to tackle is that's the nature of knowledge that we deal with or have to deal with. And what we don't have right now are really good tools for doing that in an integrated way, or what we might say is a systems way. What we do now is bits and pieces and reductionist, and then try to put the pieces back together again afterwards and so on. And so complexity is always going to be the main issue. And whether or not we've got a way to construct or start with the simpler stuff and then build and continue to manage that complexity, that's really going to be the whole thing about going forward and tackling all the real problems in life.
Amen.
All right, well, we'll continue to return to this. Let's see who watches the recording or wants to continue on, but let's just work on it when we're here, and then Shinkai just tag me or let me know how I can help with anything in the time between.
Absolutely, will do. Do you happen to have like 2 minutes after this call, or are you you'd
I
rather
have
me-
to go.
You do? Okay, I'll tag you later then. Yeah.
Thank you. All right.
Cool. Thanks.
Farewell.
Bye.
Bye.